Hello everyone, welcome back. This is Unit 13, Lesson 4, and we are on Section 6 of the notes, which deals with what we call functional groups. Functional groups are given to you in reference table R, and what they represent are things that you can put on the carbon chain other than hydrogen, okay? So what we will be doing is removing hydrogen atoms and putting on different things, depending on what functional group we have. So if we have a halide, you remove a hydrogen and you put on a fluorine or a chlorine or a bromine or an iodide. If you have an alcohol, you remove a hydrogen and you put on an OH group. Okay, if you have an ether, that's a little different. You put an O in the middle of the carbon chain. And we'll be discussing each of these functional groups in this section in detail. Don't worry, we're not doing them all in this video. That would be a super long video. Okay? When you add a functional group, when you remove a hydrogen and add a functional group, you change their properties. You will have to know how to name these, and naming them isn't bad because they provide you an example in Table R. So generally, when we name these, we're going to name them as an alkane, and then modify the name as they show in the example on Table R. Otherwise, it's kind of overwhelming to have to memorize all these naming rules. I'll walk you through a few examples, though. So we'll go in order, sort of as they appear in Table R. Halides are the first group. They're also called, if you look in Table R, halocarbons, okay? And they are formed when the hydrogen atom in a hydrocarbon is replaced with a halogen. A halogen is a group 17 element, if you remember, okay? So you'll have your carbon chain, which we represent the carbon chain. I'll draw the first one. Say you have your carbon chain, and then instead of them all being hydrogens, which I'm not going to draw in the hydrogens, you replace one of the hydrogens with a member of group 17. That's your group 17 element there. Okay? You can replace one or more of them with a group 17 element. Instead of drawing the hydrocarbon chain each time, what they have done in your reference tables is they've represented that hydrocarbon chain with a letter R. So they would say like R bonded to group 17, where the R is your normal hydrocarbon chain. Okay, they did RX, where the X represents a halogen. Okay? So you can see that they're in group 17. Typically, these are used as organic solvents and pesticides, so they spray them on crops, these halides, to kill bugs and to prevent the bugs from eating the crops. They're generally not very good things for us. They tend to be dangerous. That's why you should always wash your produce and don't go licking the grass. They're named by citing the location and the name of the halogen attached to the chain. So we're going to cite the location and the name of the halogen attached to the chain. So what I'd like you to do is draw this example that I have here. It's basically a 4-carbon chain. Okay, and we're not going to draw all the H's in. That's a waste of time. Okay, but on this N carbon, I have a chlorine. So that's the one we're going to name. So when you name these, you'd name it as it's an alkane. So 4 carbons would be butane. But it isn't butane because it has this chlorine attached. Now, I told you to use Table R's example to help. So if we go here, what you'll notice is they call this one 2-chloropropane. If what's attached is a chlorine, you add that before the name and you cite the location. So this is 1-chlorobutane because on the first carbon in the chain, there's a chlorine group. Okay? So this would be 1-chlorobutane is what we would call this halide. The next functional group is an alcohol, and alcohols have an H removed and an OH attached to the chain. So R, remember, is your carbon chain. They have an OH. Now, I didn't draw the bond between O and H, but recognize that there is one. It looks something like that. So they are formed when the hydrogen atom and the hydrocarbon is replaced with an OH group. An OH group is called a hydroxyl group. It is not the hydroxide ion. It will not dissociate. So unlike the OH group in bases, alcohols do not ionize in water. And so they will not release that OH group in water. Alcohols are polar and they do dissolve in water. And there are several different types of alcohols depending on the number of OH groups in the compound and the location of the hydroxyl group in the compound. I'm not sure. Let's just see if I talk about how we name these. Yeah, we should talk about how we name these. So I'm going to give you a generic alcohol. We'll give you a pretty basic one. Why don't you draw this one off to the side, then we'll go over the classification, which is in your notes. So draw this alcohol. Again, you would name this like it's an alkane. So it's 2 carbons. We would call this ethane. But when you're naming an alcohol, you drop the final E and you add OL in their name. So we're not going to call this ethane, we're going to call it ethanol. Okay, again, if it's more than 2 carbons, you should indicate the location with a number. So make sure that you're using numbers. You don't really need it in ethanol because it can only be on the first carbon, but make sure you're giving the location of the OH group when you name these. Okay? So there's different classifications of alcohols. You can classify an alcohol as either primary, secondary, or tertiary, depending on how many carbons are attached to the carbon with the OH group. So the example that I just gave you, this one, okay, ethanol, if you remember, that's a primary alcohol. And the reason it's a primary alcohol is because the carbon that has the OH only has one other carbon attached to it. So that would be a primary alcohol. A secondary alcohol would look like this, where the carbon that has the OH isn't just attached to one other carbon, it's attached to 2 other carbons. Okay, we don't really need to fill in the H's here. We'll just leave the backbone, I think, would be easier. Okay? So it would look something like this. Okay? And then a tertiary, so that a secondary alcohol, right, the carbon that has the OH is attached to 2 other carbons. And then a tertiary alcohol, the carbon that has the OH, you probably guessed it, isn't just attached to 1 other carbon or 2 other carbons, it's attached to 3 other carbons. So that structure would look something like that. Okay? So there's primary, secondary, and tertiary alcohols. You really just have to be able to look at the structure and identify what you have. You also have dihydroxy and trihydroxy alcohols. That tells you the number of OH groups in the compound. Like antifreeze that you put in your cars is a dihydroxy alcohol. This is the structure of antifreeze, right? It's, if you want me to draw it so that it's not, it's a little easier to draw. It's 2 carbons, kind of like ethanol, but instead of just 1 OH group being present, there are actually 2 OH groups being present, okay? And then you'd fill in with hydrogens. So a dihydroxy alcohol has 2 OH groups, and this is the structure for antifreeze. This is what you put in your car to prevent the fluids from freezing in the wintertime. And then glycerol is actually a trihydroxy alcohol. It has not just 1 OH group, but not just 2 OH groups, but 3 OH groups. So it looks something like this. Okay? There are 3 OH groups in this molecule, which makes it a trihydroxy alcohol. And again, you really just need to be able to identify those. You can go ahead and draw their structures in there. Okay? So again, I don't want you to panic because all how you know, identifying an alcohol, you look for OH, and they give you an example and how to name it here. So if you get this on the Regents exam, which you will, you kind of follow the example that's given to you in your table R. So use table R's when you have things other than hydrofluids. I think we'll do one more. Apparently I skipped from number 1 to number 2 to number 5. This should really be functional group number 3, but it doesn't matter. These are the aldehydes, okay? And aldehydes have a carboxyl group. So instead of your hydrocarbon chain, right, with just your hydrogens, one of the hydrogens has been replaced with a double bonded oxygen. And that has to be on an end carbon. That has to be on the end of the chain, okay? That's called a carboxyl group. It's a C double bonded to O bonded to H, and it's always at the end of the chain, okay? When we write its name, when you write the formula out, we would write like R bonded to CHO. CHO is the indication that you have an aldehyde. These are named by substituting the E, substituting an AL in the final place of an E in the corresponding alkane name. So for example, if we have this structure, here's what tells us that we have an aldehyde, right? It has that C double bonded to O bonded to H. You would name it like it's an alkane. Since it's one carbon, you would call it methane. But it's not just methane. It has the aldehyde. So you drop the E and add Al. This is methanal. And methanal more commonly is known as formaldehyde. It's used to preserve dead bodies and dead organisms. So this is the structure of that fixative. It fixes tissues, methanal or formaldehyde. Okay? So aldehydes always end in Al, and alcohols, this one's my favorite, not alcohol, but this little way to remember it. Alcohols have an OH and they end in OL when you name them. So that's another little trick to remember, though you don't need to. Okay? Last one today is a ketone. And ketones are very much like aldehydes, except that carboxyl group is moved to an interior carbon. So they also have the C double bonded to O, but it's not on an end carbon. It's in the middle of the chain, okay? That carboxyl group is in the middle of the chain. Ketones are named like an alkane, but you drop the E and add O-N-E in the name. So you drop the alkane E and you add O-N-E. You will need a number if there's more than 4 carbons. You would indicate what carbon it's on with a number. Common ketones that you might know are testosterone or progesterone, which are hormones found in the human body. Obviously have very different purposes. I gave you a simple one. You also know this one. This is common name as acetone. Acetone is chemically, it's a IUPAC name. Acetone is what's a nail polish remover. It's propanone. So if I were naming this, right, draw this one. There's 3 carbons, okay? 3 carbons would generally be called propane. But see how it has this carboxyl group? That tells me it's a ketone. So I drop the E and add O-N-E. Okay, so this is called propanone. Okay, there's only, remember that carboxyl group has to be on an interior carbon. So that's really the only interior carbon there is. So I don't need a number here to indicate which interior carbon. But if there's more than one interior carbon, you will need numbers to indicate which carbon that double bond to oxygen is. So you will need numbers for these to indicate what carbon that's on. Just like for the alcohols, right? I don't think we wrote it, but in case we didn't, yep, here, right? You need numbers for the alcohol, and for the halides, you'll also need a number, just like when we named them, okay? You'll need a number to indicate what carbon the chlorine's on, or whatever. You don't need it for the aldehydes, these guys, because they're always on the first, they're always on the end. Okay, so you don't need a number for the aldehydes in their name. Okay? I think that's it for the video for today. We'll finish the rest of these up tomorrow in tomorrow's video, and then your final video of the unit will be on Friday, where we talk about organic reactions. Plan on a test early next week, most likely Tuesday. Have a great night, everybody. We will see you tomorrow. Bye-bye.